So we're going to just do some basics with complex numbers. Let's talk about them first. If you have all the real numbers, what kind of numbers are there in the real number system? Give me some examples. 1, yep, integers. Good. If you take a ratio of 2 integers, what do you call that? Like 5 over 7 or 12 over 13. That's kind of a rational number. Those are things like, this is like -2, -1, 0, 1, 2. And then these are like 2 over 5, 3 over 9, 8 over 1. Those are rational numbers, like your fractions. What if you don't get a repeater, like E, which is 2.71828, pi, or square root of 2, or pi? These are called what? Irrational. You can't write as a ratio of 2 integers. 22/7 is not pi. All right, so irrational integers, this seems to be the host of all of the numbers that exist, except that's not true. There is another group that's not real. It's called complex. Complex numbers are the whole universe of numbers because they have all these real numbers in them plus y times I. What we mean by that is that you can have a 2 over 5, but you could also have 3i or 3/7 I. I is the square root of 1, negative. You can't get that in your calculator, but we define it as I because I squared is the square root of -1 times square root of -1, which is what? -1, which is kind of cool. And from there, you can do I cubed, you can do all kinds of things. What's the square root of 49? 7. What's the square root of -49? Well, this is going to be the square root of -1 times the square root of 49. So, yeah, 7, and the square root of -1 we said was I. So this seems pretty easy, but it isn't. Is there a difference between negative square root of 100 and the square root of a -100? Yeah. Which one is real? This first one. This is the same as -10, and this one is what? 10i, yeah. Now there's something called the Argon graph, where the real numbers are on the x, and y are real numbers times I on the y. We call these the imaginaries. Okay? These imaginaries are like 1, 2, 3, but times I. All right? So if we look at -10, it's going to be back here. -10 plus 0i. We're not going up any I or down I. -10 plus 0i is the square root of 100, but the opposite. Where is this going to be? Well, 10i, -10i would be down here, but 10i is going to be up in here. This is where 0 plus 10i is, and on this graph you can see that these aren't even close to being the same, are they? They're different. So we'll play around with this a little bit more. Just main thing I want you to see is that these are different. Okay, so what can you do with complex numbers? You can add and subtract them. So if I had 1 plus 3, you'd say that's 4. If I had -2i plus 4i, you'd say that's how many I? 2i, right? If you have them all together, all you would do is add the likes and subtract the likes. So this one would be 1 minus 2i, subtract 3 minus 4i. So put the reals together. These are the reals. And so it'll be 1 plus negative 3. And then this other part is going to be negative 2i minus 4i. And so 1 minus 3 is negative 2. And negative 2i minus 4i, those are likes. That'll be negative 6i. So this is my complex number, subtracting those two. So you can add and subtract. Easy? Yeah. Let's multiply. We're going to multiply these now. 1 minus 2i, 3 plus 4i. So we'll FOIL it. 1 times 3 is 3. 1 times 4i is plus 4i. Then we're going to take negative 2i times 3 is negative 6i. Negative 2i times 4i is negative 8i squared. Now what did I say I squared was? Negative 1. So you're going to have 3 plus 8. And then you're going to have 4i minus 6i. So you can see that this is going to be 3 plus 8 is 11. 4i minus 6i is negative 2i. So it'll be 11 minus 2i. There you go. You just multiply two complex numbers together. Now we can't divide. Dividing is a lie. You don't divide complex numbers. What you're doing is getting rid of the I in the denominator. What do you think we can do to get rid of that I in the denominator? Conjugate, yeah, comes back. It's almost like I did that on purpose before. You have 3 and 4i. 3 and 4i. They have the same thing top and bottom. It's like multiplying by 1. Now, if this is minus, the conjugate's going to make this what? Plus. Yep. So now you're sort of dividing these. We multiplied this top part and we got 11 minus 2i from this one. Same thing. In the bottom, it's going to be 3 times 3 is 9. 3 times 4i is 12i. Negative 4i times 3 is negative 12i. And then negative 4i times 4i is what? Negative 16i squared. Okay? So 11 minus 2i. 9. What's I squared again? Negative 1. So what is 9 plus 16? 25. And what's 12i minus 12i? 0. So this is just going to be 11 minus 2i over 25. And did you see the I disappear in the denominator? It's sort of dividing, but it's not really dividing. Now tomorrow we'll talk about why you want to do this and what the big advantage is. We'll get to that. But would you go to the homework at the end here? And what you're going to do is, here's two complex numbers, a z and a w. You're going to add them. You're going to multiply them. You're going to divide 1 over z, and then you're going to take z over w. And then where this z with the line is, z is negative 5 plus I. This is what z with the bar over it is. What's another name for z with the bar? Conjugate, right? So this is called the conjugate. Okay? See what you can do with these 6. Go to it. And then you're going to do this one. You get some more practice with this one. You'll do these quick. Can you figure out what these are? And then a little bit of pattern recognition for I different powers. And that's the assignment.